Hello, students from Chatswood High School. And today we're going to do topic 3 of electronics and microbit. So the main topic will be time, and we were planning to introduce the BitGadget kit, but we'll have to delay that because the kit has not arrived at the school yet. Okay, so before we start, some news. Recently, we had the National Science Week, and one of the topics that was discussed was recycling. And UTS had a smart bin on display, and go across to the website and have a look at it. Also, there were lots of competitions that STEM clubs entered into, and perhaps that's something you might want to consider for next year. Okay, so at UTS, this is the smart bin, and some of the students in Sydney also participated in creating that. So the CSIRO have been quite active in recycling, and they've helped a small company in Victoria to recycle glass and use it in making bricks. Okay, so we're looking forward to getting the BitGadget kit. Hope it arrives next week, and we'll do a simple exercise in sorting out which of the modules are sensors and which of them are actuators. And we'll get used to the interface board called BitMaker. And you can start thinking about how you could use it in your own projects. But for the time being, we're going to start topics that are related to physics. And this week, we're going to talk about time. And physics is a study that involves time, distance, mass, and charge. We'll be taking quite a practical approach to this, and we'll be making things like timers and watches. And next week, we'll be exploring distance. But rather than charge and mass, we'll be looking at climate. And our final topic will be to make a small weather station. Okay, so how have I used timers in my career? Well, in the biomedical engineering area, I was interested in making sure that patients did not get overexposed to radiation, either X or gamma rays, when they were getting X-ray images taken, or if they were undertaking radiation treatment. And it was important that the timer could terminate the radiation beam on time, so that the patients were not overexposed. Later, when I moved into transport, I used timers for all sorts of signs, including road signs and passenger signs. And here are some of them. So on the motorways, all of the signs that you see there, I was involved in putting them on the roadside. And they're used for road safety. And I also put in many of the signs in school zones. So you probably have seen those. You might even have one outside of your school. Well, this was one of my projects. And on the road, signs like this help motorists estimate how long they have to go to complete their journey. So this is a variable message sign, and it's used as a timer. And even in traffic lights, I've used timing to go through the various phases so that we have a minimum time for red, the warning, yellow, and the green phase. So timers are used in all of these devices in transport. So I'll be using a mind map, and each project will look at the objective or the requirements, we'll examine the components that are needed for the project, and we'll do projects on clocks and timers. And finally, we'll review how we went, and I'll give you some references so you can follow up. So the objective is to explore and make a clock and a timer. And we'll be using sensors and actuators, but we'll have to delay that till next week. We'll be using the actuator on the microbit itself. We'll learn a bit more about coding, how to use extensions on MakeCode. And one of those extensions will be a software real-time clock. And perhaps you can explore clocks, how accurate are the clocks, and the history of clocks, where did they come from? So while we use them in many, many applications today, and it would be very hard to do things without clocks and timers. Okay, so the components that we'll use next week, hopefully when BitMaker arrives in the BitGadget kit, we will put together a clock based on the 4-digit display. But for this week, we'll start off with a simple watch, and we'll move on to a watch using a software real-time clock, which will be more accurate. And as a challenge, you can create a binary watch that just uses the microbit LED array, and it shows simultaneously hours, minutes, and seconds. And projects that we might do today also include the time timer and a railway crossing, but it's more likely that we'll extend these till next week. Okay, so the simple watch, the requirements are to maintain hours and minutes by the microbit and display the time on the microbit LED array. And for the simple one, we'll just adjust the minutes. So here is the code for the simple watch. And I'd like you to go ahead now and construct this. And I'll give you a few minutes, and we'll review how it went. So on the startup, you set 3 variables. There'll be a variable for the hours, minutes, and seconds. And what we're doing here is setting the hours to 1600 hours, the minutes to 0, and the seconds to 0. So we're setting the initial time for our watch at 4 p.m. And in the forever loop, we wait for a second. And this is the fundamental unit and instruction that's keeping our time. And after a second is up, it then checks the seconds. It increments it first, and if it is at 60, it will reset it to 0. Then increment the minutes. And if the minutes are 60, we increment the hours by 1. And after we've done that, we show the hours and we show the minutes. And to adjust our time, we're only going to adjust the minutes. So when we press button A, we'll be able to do that. And there it is. On the right, we can see that when we adjust button A, we increase the minutes. And when we press button B, we decrement the minutes by 1. So after you've downloaded into your microbit and you've tested it, did it work? And are there any problems with this particular watch? Okay, to improve the display, next week we'll use the Grow 4-digit display, which is one of the modules that's extra to the BitGadget kit. And our next project, we're going to make the timer a lot more accurate by using a software real-time clock. But we'll still display the time for this week on microbit's LED array. And we're going to use a MakeCode extension called the software real-time clock. So to get that, you have to go and select extensions and then type in RTC. And right at the bottom, you should be able to see the software-based real-time clock, just like the icon on the right here. So select that, and you'll get added to your toolbox the time and date instructions that you can use in your program. So explore those and think about how you might be able to use it. So you might notice that on the right, you can set the time using AM and PM, but we're going to use the 24-hour time, because that means that the time is represented by simple variables, integers, whereas if you use the AM and PM, the variables are represented as an object. Okay, so to actually use that time, we go to the next set of statements, and the one we'll be using will be set time as a number. And that is the way that we can access each of the variables from time, minutes, seconds, month, day, and year. And here's our clock. So what I'd like you to do is to go ahead and construct that on MakeCode on your Chrome browser and see how it goes. Now, we're only going to adjust the minutes in our simple clock, and we'll use button A to increment the minutes, use a bit of simple maths to do that, and we'll decrement the minutes by pressing button B. But this time, between the hours and the minutes, we'll have a colon that separates the two variables. So you can quickly identify whether it's time or minutes that's currently being displayed on the microbit LED array. Okay, so there's a closer look, and I'll give you a few minutes to construct that. Okay, so as an improvement to that, we'll adjust not only the minutes, but also the hours. And I'll post this on the website, and it will become the LED 2.hex program. LED.3 or LED 3.hex. So there's a little bit of extra code there. And I'll go through that either next week if you want me to, or you can explore that yourself. Download the program from Dropbox and see if it works on your computer. Okay, so the challenge, and I'll let you do this on your own, is to make a watch that only uses microbit's LED array, and it's going to show the hours and minutes and even seconds. So we'll have seconds on the top, and we'll have minutes, and finally hours. So there's a challenge, and if you have time to make that during the week, we can talk about that next week. Or alternatively, you can see the result on my YouTube channel. Okay, so the next series of projects we're going to do is on timers, and it's based on a timer which is used to help people manage their time, either in recreation, study, or doing duties in the house. So in this time timer, it shows a mechanical display, and the display that I've got here at the moment shows that there's 45 minutes left to finish the task, and then it counts down. So when it gets to 0, there's a sound buzzer goes off, and there's no more color display on the disk. The next project we'll do after that is a railway crossing, and the timer is going to set the time that the boom gates are down to stop traffic from going across the railway crossing. And it just lets the train go through, and it's another road safety device. So let's start off with time timer, and we're only going to use the microbit display, and it will function just like the commercial time timer, but it will use the microbit's LED array. And you can see how it works on the commercial timer. As you time down, you set the time, and then you time down. So the requirements on our project is to create a time timer, and using the LED array on microbit to represent the remaining time. So on our simple prototype, we're going to set each LED to 5 seconds. And after 5 seconds, the LED will be extinguished, and then the timing moves on to the next LED on the same row. And if all the LEDs, all 5 on the one row, are extinguished, it then moves on to the next row until you extinguish all 25, and then time is up. So when time is up, we'll show time up on the microbit LED array. And how would you use this? Well, you might use it to time how long you should wash your hands. And it's interesting that most people don't spend enough time washing their hands. So it shouldn't take just 5 seconds, perhaps 25 seconds. And perhaps a timer like this might help people wash their hands correctly. But you might also use it in cooking. And an example could be an egg timer to make sure you don't overcook or you don't undercook your eggs. And here's the program. So go ahead and see if you can construct that, and we'll talk about the results when you're finished. Okay, so what we're doing is creating 4 variables. The number X and the number Y represent where the current LED is timing down. And it's going to scan across from the upper left, move across the row to the right, then move down to the next row, which is represented by the number Y. So X represents the number along a column, and each row is represented by the number Y. So each increment of time is represented by the variable time left, and that's going to be set to 5 and then multiplied by 1,000 to give 5 seconds. And in a real timer that you might use in everyday life, you might increase that number to a more realistic quantity. And the maximum number is the maximum number of LEDs on either a row or a column. And in the forever loop, we're using the start timer, which is a logical variable. And if it has been set, then we unplot the LED at the X and the Y position. Then after we've done that, we wait 5 seconds. And we then move on by incrementing the x. And if that x equals the maximum number, we increment y and reset x to 0. And if y is at the maximum number, we then show on the microbit LED that time is up. So for button A, we start the timer. And when we start the timer, we set the logical variable of start timer to true, and we turn on all the LEDs. And we start unplotting the first one. And we set the position to 0, 0. So in button B, if you want to stop it early, you press button B, and that sets the variable start timer to false. And if you want to increase the units, instead of 5 seconds, press button A and B, and it will add an additional 5 to the time left. But in this particular example, it only resets the time left to 5. But if you press the logo button, it is the one that increments the time left by an additional 5 units. Okay, so how did it go? Did you get your time timer on microbit to work? How can you make it better? And where would you use it in your life? Okay, so that will do us for this week. And we might review on what you've learned this week and how you went with accessing the extensions on MakeCode. So what's a RTC and what types are there? You only used one type today, but there are other types that you could have used as an alternative. So how accurate is your real-time clock? And can you think of any other projects that you might use this? Okay, so that'll do it for today. But there are some references in getting ready for either next week, if our BitGadget kit arrives. You might like to explore some of the things you can do with it. My mind map and presentations are all available on Dropbox. And this video will also be available on the YouTube channel. If you want to look at any of the software for the clock and the timer, they're also available on Dropbox. And that's all for this week.